Hello everyone and welcome to MV Tutors. I'm Zulu and I'll be looking at question 1 with you guys. Paper 2, Gauteng June exam. It's a very cold day today. There was some snow in Joburg. As in Pretoria, I'm just experiencing hectic coldness. Hence, I'm here in my PJs to do this paper because someone asked and said, please do paper 2. We've been waiting. And I'm like, okay, if we're gonna do it, let's just go in. All right. So yeah. Please don't forget to like our videos and subscribe to our channel. And please keep the comments coming. Yeah, we try by all means to answer all of them in a timeliest manner. And yeah, whatever criticism you have, how we can improve, that will help because we're here to serve you. We're taking time out from our busy schedules to help you guys to make sure that you're ready for your final exams and you actually do very well. So, without wasting any more time, let's get to it. Someone asked if we could also show mark allocation. Guys, I'm not a teacher, so when I do a memo, I just do it, but I'll try, okay, to see how we can get to show how they might allocate marks. All right, so for question 1, they say ABCD is a quadrilateral on the Cartesian plane with vertices A, B, C, and D. Okay, so we have all the coordinates except for D, where X is unknown, right? And it's actually, yeah, the X-intercept. So now 1.1 says, please don't mind the handwriting on the paper. It says determine the gradient of AC. Guys, this is where you have to collect your marks. Please, you can't go wrong. Yeah, I was helping my husband mark papers and sure, grade 11, grade 10, some of them are saying gradient is delta x over delta y. Please, 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 please make sure you do not lose marks in these simple questions. This is where you collect them. So if I look then at the gradient of AC, I will take the y-coordinate of C minus the y-coordinate of A over the x-coordinate of C minus the x-coordinate of A. And do we have everything? Yes. So the y-coordinate of C is -3 and of A it's 1, right? X-coordinate of C is 5 and for A it's -3. Okay, it's only 2 marks. So you get 1 mark for substituting, all right? And then another mark for getting the right answer. So -3 minus 1 is -4. And then 5 plus 3, that is 8. And does it make sense that we get a negative gradient? Yes, it does, because it's going downwards from left to right. And yeah, -1/2. So I guess the 2 marks is for substitution and also getting the answer. Okay, now 1.2. What are we looking for? Calculate the equation of AC. Okay, so for an equation of AC, you need a gradient. So we already calculated it. It's -1/2. And a point. You can choose any point. So let's go with point A. Okay, there are various ways of getting the equation of a line. You could have used both points A and C. I just prefer using a gradient and a point. And so I go to my equation, y is equal to mx plus c, and I substitute everything I know so that I can work out the value of c. Okay, and we can see we're expecting that c will be a negative value because the y-intercept is on the negative side, right, of the y-axis. So in the place of y, put 1. In the place of m, we put -1/2. In the place of x, we put -3. Okay, so now we have 1, and we have -1/2 times -3 is 3 over 2. We take it to the other side, it will be -3 over 2. Okay, so therefore c would be equal to -1/2 minus 1. We have -1/2. Okay, so therefore the equation of AC is y is equal to negative a half x minus a half. Okay, so there we are. Oh, mark allocation. Geez, depending on how you calculated this, I guess getting the value for C, or substituting incorrectly, getting the value of C, and writing out the equation. Okay, this is me just guessing where the marks are gonna go. Okay. Yeah. So now 1.3. Okay. Yeah. 1.3, calculate the angle of inclination of AC. So we can see we have our x-axis over here, and AC does that. So whenever you calculate your angle of inclination, please make sure you start from the x-axis and you work your way to the line, okay? So that is, I'm gonna just call it theta. So that is your angle there that you're gonna work out. And the wonderful thing about this is, you know, the equation that tan theta is actually equal to the gradient. And since we're looking at the line AC, it would be the gradient of AC, okay? So tan theta is equal to the gradient, which was negative a half. And now theta will be arctan negative a half. Okay, so here, what you're gonna calculate, let's just take out the calculator. You're probably gonna calculate this negative angle over here. Okay, so let's see what we're gonna do with that. Where's the calculator? There it is. Ooh, oh, we have a new calculator. Okay, so shift 10, negative a half. Okay, so like I said, we actually get negative 26,57 degrees, but that's not the angle. So what we just calculated now is this angle over here. And what are we going to do to get theta? We're actually going to add 180 because this is on a straight line, all right? So we're going to add 180 so that we can get the actual value, all right, of theta. So it is 153,43 degrees. All right. And I believe you will get, this is 3 marks. So probably remembering that you're going to have to use tan theta. So for the equation, the substitution, and probably the answer. Okay. And then 1.4. Determine the coordinates of D. All right. There is D. If AC is determine the coordinates of D if AC is the perpendicular bisector of DB. Okay, so if it's a perpendicular bisector, it means that AC is perpendicular to DB. All right, meaning the gradient of AC times the gradient of DB is equal to -1. Okay, so yeah, so the gradient of AC is -1/2 times the gradient of dB. Okay, I'm going about this the long way. For those who can just see it, just do it. So now if we take it to the other side, we're going to get 2. So 2 times -1/2 will give us -1. So that's the gradient of dB. So that's 2. Now that we have the gradient, what are we going to do to get the coordinate of x? Yes. Oh, the coordinate of D. Yeah, basically the coordinate, the x coordinate. So what we can do, you can get the equation of the line, all right? And once you get the equation of the line for dB, because you have a gradient, you also have a point B. And then what you do, you work out the x-intercept because y is 0. So there are many ways of doing it. If you did it in a different way, please do share it in the comment section. So we have our gradient, which is 2. And we have a point there, which is 2 and -4. So let's substitute it in our formula, y is equal to mx plus c. So y is -4, the gradient is 2, x is 2, and we can then get c. Therefore, c would be equal to -4 minus 4, which is -8. Does that make sense? If we look at db, yes, it does. If you were to take down the line, you were to extrapolate it, db, and extend it towards your y-axis, you would see that it does cross somewhere there at the bottom. So -8 does make sense. Okay, so now what is the equation of my line? The equation of db is 2x minus 8. Now we need to get the x coordinates. So I'm going to say, to get the x-intercept, y has to be equal to 0. Therefore, we have 0 is equal to 2x minus 8. And if we solve for x, we take 2x to the other side. We can then see that x is equal to 4. Therefore, we can then get the coordinates of d, which is basically 4 and 0. Okay, so that is 5 marks. Where would the marks be allocated? Okay, well, it depends. It depends what you used. But obviously an answer for the coordinate, probably a right answer for getting x, the x coordinate, the right equation as well, getting the c value, getting the gradient. Nah, I think that's where your marks would actually come from. So yeah, but basically D is 4 and 0. And now let's move on. We have strong winds out there. I hope you guys are keeping warm. 1.5, hence deduce that ABCD is a kite. Okay, so this is where you get a practical question. And remember, guys, you need to remember matric is like an accumulation of everything you've learned from grade 1. And quadrilaterals, you have covered them. I think they were introduced properly in grade 10. All of them. So a kite was one of those. And so how can we prove that ABCD is a kite? Let's just remind ourselves, what are the properties of a kite? A kite is like two triangles that are congruent. Okay, yeah, so basically this side would be equal to that side, so we would get, you could, get the lengths, calculate the lengths using the distance formula. Also, those sides should be equal in length. Remember, this is a common side, so obviously that one has the same length. This is perpendicular. They already told us, okay, we already know that DB is perpendicular to AC. Okay, that was given. All right, what else? This length over here is equal to that length. That angle obviously equal to that angle, and this one, yeah, this angle as well equal to that angle. What else do we know about the kite? I think that is basically it. So what are we then going to do? Yeah, so here's what we're going to do. Remember, we were also told that AC is a perpendicular bisector. Not only is it perpendicular to DB, but it bisects DB or BD. Okay, so if I were to label this, that's C, D, A, B, and that's M. So basically DM is equal to MB. And we have already indicated it there, that those lines have to be equal. So with this given information, you could conclude that it's a kite, but I mean, 3 marks, you'd want to calculate something, right? So I think we can then say, let's check out if BC is equal to CD. And this is where you test if D is actually, did you calculate it correctly? Because if you didn't calculate it correctly, then the lengths are not going to be the same. So let's just go about it and say BC, distance BC is equal to the square root of XC minus XB, and then we square it. yc minus yb, and you square it. Okay, so the x-coordinate of c is 5, and that of b is 2. Y-coordinate of c is -3, and that of b is -4. Okay, so 5 minus 2 is 3 squared, that's 9. Minus 3 plus 4 is 1 squared, that is just 1. And so we get that BC, the distance of BC is actually root 10. I think it's okay to leave it as root 10. Then we can work out the distance of CD. Okay, I'm just gonna substitute. I'm not gonna write down the equation again. It's only 3 marks, guys. D, so we have 4 minus 5 squared plus the y-coordinate is 0 minus -3. So 4 minus 5 is -1. -1 squared is just 1. And 3 squared, okay, that will be 9. So we can see that it's also root 10. Okay, so length BC is equal to CD. All right, so we have that the sides are equal, those ones it was given that it's equal, and also you have a perpendicular 90-degree angle over there. So we can safely conclude, okay, that ABCD is a kite. And I must say that if they say hence, it means the previous question, you need to use that answer in order to determine the following answer. Use the information that you already know in order to get the next, question. So I think by showing that, one of the sides or the two sides are equal, you get a mark. And probably also, using what has been given, okay? Based on the previous question 1.4, that's where you also get marks. And then that's where you get your 3 marks. Okay, 1.6, we are there. We're almost at 21 marks. Wow. Okay, I think this is a nice 21 marks to get. But let's just see. Let me not get ahead of myself. Let's see what 1.6 has in store for us. It says calculate the area of triangle ABD. Let me just draw it out. Okay, I'm not putting it, yeah, I'm just gonna draw it straight up. I'm not gonna put it in a slanted form. So there we have D, and then we have B. Okay, so what do we know? Calculate the area of triangle ABD. Okay, so we already know that this is the perpendicular height, right? And we can use our area formula where we have half the base times the height, okay, which is what exactly? Your base is BD and your height is AM. Do we have M? M is like the midpoint. Okay, so BD, yeah, we're gonna have to calculate it. Okay, let's just go. So let's get the distance of BD as basically the x-coordinate of D minus that of B. Okay, let's just write down the formula. And it's all under a square root. So x-coordinate of D is 4. And that of, wait, didn't I calculate this? No, it was CD. Okay, B. So that's 2. And then YD, that's 0. YB, it's -4. So it's going to turn into a positive. Please excuse me, guys. Ish, the flu has gotten to me. So 4 minus 2, that's 2. 2 squared is 4. And we have 4 squared, which is 16. So now we have root 20. Okay, I would leave it there for now. And then our perpendicular height, which is AM. Firstly, we need to get M. Okay, so we're going to use the midpoint formula. Midpoint of BD. Okay, so the x-coordinate of B plus the x-coordinate of D, and we're dividing that by 2, the y-coordinate of B plus the y-coordinate of D, and we're going to divide that by 2, and you can see that M should have a negative y value, all right? Because, yeah, negative y value, positive x value. So 6 divided by 2, that is 3, and minus 4 divided by 2, that's negative 2. Okay, so those are the coordinates of M. And now we can calculate the length of AM. Okay, so distance AM. Okay, so the y-coordinate of M minus the y-coordinate of A. It's fine, doesn't matter which one you start with. X-coordinate of M minus the x-coordinate of A. It's not like the gradient where there you can make a fatal error. All right, so the y-coordinate of A is 1. Sorry, of M. Yeah, let me start. Y-coordinate of M is 3, and that of A is 1. Oh, what am I doing? Y-coordinate, negative 2. And that of A is 1. X-coordinate is 3 of M, and that of A is negative 3. Okay, let me just take it up. I don't know why I'm squeezing myself in the corner. I can just basically write somewhere else. Minus 2 minus 1 is minus 3, and that squared is 9. 3 plus 3, that's 6, and 6 squared is 36. So let's just do that. Okay, and then 9 plus 36. Let's just check. 45, yeah. Okay, so root 45. So now we have our perpendicular height, which is AM. Yes. And we have our base, okay? And now we can calculate what the area is. So therefore, area, let's just remind ourselves, half base times height. Our base is BD, so that's root 20. And our height, that's root 45. This is where we take our calculators out. 0.5 multiplied by root 20 and multiplied by root 45. It's a nice rounded answer. So we have 15 units squared. Okay, they didn't give us the units there. No. So that is the area of triangle ABD, and we are done with question 1. Oh, I forgot with the mark allocation. So where would you get marks? Well, the equation, you have to realize that you can just use the formula, and also getting BD, getting the midpoint, which is M, then getting the distance AM, so that's like what, 1, 2, 3, 4, and finally getting the answer, and that's where you get your 5 marks, and it's all good to go. Okay. Hello everyone, and welcome back to MV Tutors. So and I'll be looking at question 2 with you guys. So just continuing with the Gauteng exam that was written by Matrix. This is not the May-June supplementary exam. This is the matric paper in the Gauteng region. All right, so let's see. It says in the diagram below, Q is the center of the largest circle, which touches both the x-axis, and the circle centered at P. Okay, so we can see where it touches it, right there, and there it touches the x-axis. Okay, so basically, if I have a look here, this would be distance M. Okay, and that would be distance Q. Let me not make all these marks. Yeah, but yeah, that is just, oh, what am I doing? Yes, that's M, and this value over here is 15. Yes, that's how I wanted to put it. All right. Oh, and I see they've written 8 here, so that must be the radius. But anyway, The circle with center P has the y-intercept at A. So we can see it over there. And has the equation x minus 3 plus y minus 3. So I can already see the center of P, which would be 3 and 3. And 25, meaning that the radius is 5. Okay. The radius of the circle centered Q is 8 units. So, okay, so I know that M is actually 8. Ne? Yeah, MK8. Okay, so 2.1.1. it says determine the equation of the circle with center Q in terms of x, y, and m. So the equation of a circle that is not at the origin would be x minus a squared plus y minus b squared is equal to r squared. So let's just substitute what we know. We know that the x, or rather a, the value for a is 15. So we're going to have x minus 15 squared plus y minus m, okay, squared is equal to 8 squared, okay, which is simply 64. I don't know if you leave it as 8 squared if you get a mark. All right, but I would just simply make it 64 just to be safe. All right, and now we have it in terms of x, y, and m, and that's where you get, how many marks is this? Oh, 1 mark. All right, so it's basically substituting what you know. And now 2.1.2, determine the value of m. Okay, so we have already established that m is actually 8, but that's 2 marks. Are they expecting us to to explain why? Yeah, guys, I mean, you can see here the distance from the center to the circumference is m. All right, so your y coordinate is equal to m, and m is equal to the radius. So I would say m is equal, yeah, the distance from the center to the circumference, which is r. Yeah, m is equal to r, and r is equal to 8 units. I don't know how else to expand it. It is what it is. I guess you get 2 marks. All right, and then 2.1.3, determine the length of PQ. Okay, so we have the coordinates of P, and we also have the coordinates of Q, so we're just going to use our distance formula. All right, so the distance formula for PQ is equal to the y coordinate of Q. Let me start with x, actually. X coordinate of Q minus the x coordinate of P squared, y coordinate of Q minus y coordinate of P squared. Alrighty, so the x coordinate of Q is 15, and for P, we've indicated it here, it's 3. Y coordinate of Q is 8, and for P it's 3. So we have 15 minus 3, which is 12, and 12 squared is 144. 8 minus 3 is 5. 5 squared is 25. And then we have 9. 169. Isn't that 13 squared? Yeah. So PQ is 13 units. Is that what they asked you? Is the length of PQ? 2 marks. So I guess the 1 mark is substituting into the right equation and then getting the answer. Please don't forget the term units, okay? If they were not given, like centimeters or meters or anything like that, just put their units. Now 2.1.4, calculate the coordinates of A. So A is the y-intercept, as we were told. We're given the equation for the smaller circle, right? So we have there x minus 3 squared plus y minus 3 squared is equal to 25. And if they want the coordinates of A, which is the y-intercept, we know that x has to be 0 for the y-intercept. So we're going to say 0 minus 3 squared. And let's just multiply this out. So we get y squared minus 6y plus 9 is equal to 25. So we have 9 plus y squared minus 6y plus 9 minus 25 is 0. And then we're going to just write it out nicely so that we have our quadratic formula, which is y squared minus 6y. So 9 plus 9 is 18, and 18 minus 25, and we're going to get negative 7. Just make sure, yes, negative 7. This is why we have calculators, to make sure. And when you think about the factors of 7, 7 is a prime number, so it's only 1 and 7, right? And we're going to have negative 7 plus 1. Okay, so y can either be equal to negative 1 or y can be equal to 7. Now, if you have a look there, the negative 1, yes, it's there, and the 7 is there. But since we are getting the coordinates of A can only be equal to 7, not minus 1. Okay, so therefore A is 0 and 7. All right, and that is 3 marks. So those 3 marks, I presume that it's ensuring that you substitute 0 into the equation. You get your quadratic formula. So you have your, what do you call them? Your values for y, and then ultimately you get the coordinate of A. This is me assuming how the mark allocation would go. And then 2.1.5, determine the equation of the tangent to the circle with center P at A. Okay, so you have your circle there with center P and A somewhere around there. And we need the equation of the tangent to the circle with center P. So basically what I would do is, it's 4 marks. I would get the gradient of this line, which is the gradient of the radius. And I know that the gradient of the radius minus the gradient of the tangent will have to be negative 1. Remember, line from center to circumference, where you have a tangent line, the radius is always perpendicular to your tangent. Okay, so let's start getting the gradient of the radius, okay, which is basically AP. We have A and we have P. Let me just write down what P is. I think we said it's 3 and 3. So the y coordinate of P minus that of A divided by the x coordinate of P minus that of A. So the y coordinate of P is 3 and that of A is 7. The x coordinate of P is 3 and that of A is 0. So we have minus 4 over 3. Is it a negative gradient? Yes, it is. Okay, so we have our gradient. Now we know that the gradient of this tangent line would be equal to 3 over 4. Because if you multiply 3 over 4 times negative 4 over 3, you're going to get negative 1. Okay, so now that we have the gradient of the tangent, and we have a point, which is A, right? We just calculated it at 0 and 7. We can then get the formula, not the formula, the equation of the tangent. So y is equal to mx plus c. In the place of y, we put 7. And then for your gradient, it's 3 over 4. Why am I even calculating this, guys? Obviously, c is going to be 7. Blonde moment, but it's fine. So y is equal to 3 over 4 x plus 7. That is the equation of the tangent to the circle with center P at A. And that's it. Before we move on, let's just allocate the marks. So this was 4 marks. I think one thing is to recognize that the radius is perpendicular to the tangent. Therefore, the gradient will be equal to -1. Then getting the gradient of your radius, getting the gradient of your tangent, and finally getting your equation. Okay, so now 2.2, two other circles are given. One has center K and equation blah blah blah. The other has center T and equation blah blah blah. So now 2.2.1, determine the center and radius of the circle with center K. When it comes to circles, guys, you need to make sure that you know how to complete the square. It is important. Okay, so if you've managed to slide through the cracks, seep through the cracks over this time, please, this is the time where you really need to make sure you know how to complete the square. So let's look at it. We have equation x squared minus 6x plus y squared plus 4y minus 12 is equal to 0. Now I'm going to complete the square for x, and I'm also going to do it for y, and I'm going to take all the constants to the other side. That is the strategy. Okay, so let's start with x. So I have x squared minus 6x. Then I'm going to add, all right? So we're going to take the coefficient of x, which is -6. We're dividing it by 2, and we're squaring it. We're going to take the very same value and subtract it. Okay, so this is all for x. Then we're going to deal with y. Ooh, I'm going to run out of space here. All right, again, coefficient of y divided by 2 and square it, and we're going to subtract the very same thing. All right, and then we have minus 12 is equal to 0. Okay, so that's for the y. And then what I'm going to do then is focus on this portion over here. I'm going to group that. Okay, so basically I have x squared minus 6x. -6 divided by 2 is -3. -3 squared is 9. Okay, so I have that. And I'm gonna, so this is 9 here. So I'm subtracting 9. And I'm gonna say y squared plus 4y. 2 squared, that's gonna be 4. And I'm subtracting 4 and I'm subtracting 12, making it equal to 0. So I'm gonna take all the constants to the right hand side of the equation. And here, I'll just say x minus 3 squared plus y plus 2 squared, and that is equal to -9 minus 4 minus 12. So 9 plus 4 plus 12 is 25. If I take it to the other side, so that's basically r squared. Okay, so I'm gonna now finalize it and say x minus 3 squared plus y plus 2 squared is equal to 5 squared. Okay, or you could have left it like that. I think that's still gonna be fine. They just said determine the center. Oh, determine the center and radius. Okay, I think from here, you don't have to take it there. You could just say that the center is 3 and minus 2, and the radius is root 25, which is 5. Okay, so that is the center and that's the radius. So that's 4 marks. I think a mark for getting the center, a mark for getting the radius, a mark for knowing how to complete the square, right? And then getting the equation of the circle. Now 2.2.2. Calculate the distance between the centers K and T. All right, so you have K, which has a center of 3 and -2. And you have center, so T is 12 and 10. All right, and it has a radius of 10, whereas K has a radius of 5. Now we're getting the distance between K and T. It's only 2 marks. Yes, it is 2 marks because you're going to take your equation, You're going to substitute and you're going to get an answer. So substitution, first of all, and another is for the right answer. Okay, so x coordinate of t minus the x coordinate of k, and we're going to square it. Y coordinate of t minus y coordinate of k, and square it. So the x coordinate of t is 12 minus 3. Y coordinate is 10 minus 2, which is plus 2. And then we have 9 squared, which is 81. And you have 12 squared, which is 144. I am definitely taking my calculator out. I won't even bother trying to work it out in my head. So that's 15. So the distance between the two centers is 15 units. Don't forget the units portion. And this is 2 marks, guys. 1 mark for getting the answer, the other mark for substitution. And then 2.2.3. At how many points do the two circles intersect? Motivate your answer. Ah, this is the application part of circles that I have forgotten. Yes, there's a way of testing if circles intersect at one point, and I covered it in the video for circles. So I'm gonna have a look at it now and come back. But yes, so there's a way of determining if two circles intersect at 2 points or 1 point, and it's basically to do with the distance between the radiuses. Yes, I think the distance between the radiuses. If it's a certain amount, you get this. If it's not, you get that. Let me get that video and let's solve this question here. All right, so I found the video. I hope I remember to put the link in the description. But this is how we do it. So you can either have circles that are touching at one point internally or externally. All right. So basically, if you get the sum of the radii and it's equal to the diameter, or no, not the diameter, it's equal to the distance, right, between the centers. Remember, we determined the distance between the centers, right? We got 15 units, I think, or 13. We'll check. So yeah, they either touch externally or internally. So we need to look out for the distance between the centers, which is 15 units. Okay. And we need to check what is the radius for 1, what is the radius for 2. So they either touch internally or externally at 1 point. But what happens if they touch at 2 points? Because we need to determine, like, is it touching at 1 point? Is it touching at 2 points? Let's have a look. I moved to forward. I just need the notes. Now, if two circles touch at 2 points, okay, yeah, this is actually more here. Yeah, no. Okay, now I don't know where my stuff is. But yeah, circles will intersect at 2 points when the difference between the radiuses and the distance between the radius and the sum. So basically, this is at 1 point, okay? Now at 2 points, we need to get the difference between the two radiuses. And then you have the distance between the two radiuses. So if it supports this statement, then it touches at 2 points. All right, so let's get back to that question. The radius for, let's say radius of K and radius of T. Okay. K and T everywhere. I'm taking time to answer this with the hopes that if you ever come across this question in the future, you know how to tackle it. All right, let me just use a different colored pen. So basically the radius of K, we found it to be, what was it? K's radius was 5, and then T's radius is 10. Okay, so we have 5 and we have 10. Okay, so there we have 5 and 10. Okay, and remember the distance between the two radiuses is 15 units, so 5 minus 10 is definitely not there. But yes, 5 plus 10, so they actually touch at one point. Out of curiosity though, let's check if this doesn't apply. So K, which is 5 minus 10, let's see. So we know the distance is 15, right? And then this is 15. So this is minus 5. So this part, yes, that's true. But here, it ain't true. It's actually equal. So we can then conclude from this statement that at how many points do the two circles intersect? They intersect at one point. And was it external or internal? It was internal. What was it now? I forgot again. It was external. It was an external, but they didn't ask for that, so there's no need. So they touch externally at one point. Okay, and that is 2 marks. So just to say they touch at one point and showing how you got it, that is how you're going to get your 2 marks. And that's it for question 2. It was a nice question. See you again next time. I'm not sure when that's going to be. But I hope you're enjoying the holidays. Next week, schools are opening. I hope you are ready, well rested, and ready to just pick up where you left off and aim for that distinction. Hello, everyone. So I'm back. I was tempted. I thought I was going to end with question 2, but I saw trig, and I was like, let me try this trig out. And this is where a lot of you get tricked. You get tricked by the trig. So let's see. It says simplify without the use of a calculator. So we have sine squared 360 minus x. I'm going to write it like this. I'm going to say sine 360 minus x. Then I'm going to put the square root out, the square outside. Okay. This is another way of writing it. And if you get confused with it being here, please just take it out so that you can see clearly what's happening. And then it's minus, so we have cos x minus 180. All right, and then we have tan negative x and sine 90 minus x and cos 360 plus x. It is all divided by sine 180 plus x. At this point, please draw for yourself a Cartesian plane just to remind yourself what's what. I'm going to use x. So this would be 180 minus x. This would be 180 plus x. And that would be 360 minus x. Okay. This is where we have 0. That's 90, 180, 270. 360. Okay, that helps. Now let's start with the sine. So 360 minus x is in the fourth quadrant. That is where sine is negative. All right, so we have negative sine x, negative sine x, and all of that would be squared. Okay, then you have cos x minus 180. So basically, if you have x, you are starting here. And now instead of going plus 180, clockwise like we're used to, you're basically going to go minus 180. So you're landing in the third quadrant, and cos is negative in the third quadrant. So you're going to put negative cos x. Then you have tan negative x. So tan of a negative angle, the same with sine of a negative angle, will be equal to negative tan x or negative sine x. It's only cos of a negative angle that is equal to a positive angle. And if you were to draw the function, you would see that actually cos is reflected about the y-axis. So you can see if you were to say tan of negative 45 and tan of positive 45, you get a positive answer. Okay, but it's not the same when it comes to sine and tan. Yes, because sine would look like this, so, and then it would look like that. So in this case, if you have a negative angle and a positive angle, it would yield a negative answer, positive answer. Okay, hope you get it. Even tan works like that. But let's get back to this question. So we have negative tan x. Then you have sine 90 minus x. So the 90 minus x means that we are in the first quadrant, so we know that it's a positive answer. But the sine and the 90, that changes it to a cos. Okay, so we have positive cos x. And then cos 360 plus x. So basically we are here in this quadrant, 360, and then we add x. So we're in the first quadrant, and if you're in the first quadrant, cos will be positive. Alrighty, and that is divided by sine 180 plus x is in the third quadrant, and there sine is negative, so we have negative sine x. Just put everything in brackets. All right, while we're here, this is where marks are really allocated, okay? So you get 1 mark for each operation. So at least here they give you a chance, you know, so that if you mess up in the next part, at least you got some marks somewhere here. All right, so now negative sine x squared will just be positive sine squared x. Now let's start canceling things out. So yeah, I think the negative and the negative can cancel. The negative and the negative becomes a positive. So I have cos x multiplied by sine x. So the identity for tan is sine x over cos x times cos squared x. And we are dividing by sine x. Alrighty, so sine squared x plus, so now the cos and the cos can cancel, the sine and the sine can cancel, and we are pretty much left with cos squared x. And we are happy when we see that, because we know that sine squared x plus cos squared x is equal to 1. Okay, so where are the marks going? 1, 2, 3, 4, 5, 6, 7, 8, I believe. So those are the 8 marks. It's so boring. What's boring? You're saying maths is boring. Maths is boring? What? Are you done recording? No. Go sit with daddy, my baby. Okay, now 3.2, if beta is in that domain, is an element of negative 90 all the way to 270. I can't believe this boy. He says maths is boring. Oh, no. Maths is not boring. He better not grow up with that mentality. Not in this house. So beta is an element of negative 90 to 270. And we need to determine beta without the use of a calculator. So what do we have? We have cos beta plus 80 degrees is equal to sine negative 300 degrees times cos 45 degrees all over cos 405 degrees. Okay, so we are going to simplify what is on the right hand side and try to write it in terms of sine, in terms of cos, sorry, so that we can then make the angles equal to one another, get a general solution, and then solve for beta and ensure that it actually fits in with this domain. All right, so sine of a negative angle is just negative sine of that angle. And then we have cos 45. Now cos 405, I'm going to draw the Cartesian plane. okay, and just see where is cos 405 going to fit. I don't know if that was a typo, 405, or if it actually, says something. So multiples of 90, this would be 450. So 405 is in there. So if I want to know what the value is, I would say 405 minus 360, and oh, okay, so that is 45. So 405 is equivalent to 45, okay, in the first quadrant. So we have cos 45 there. All right, so this is just something on the side. Now the cos 45s cancel, and we have negative sine 300. Now sine 300 is in the fourth quadrant, right? You can see there. So we have negative sine 360 minus 60. That is what will give us 300. And the negatives cancel, so I'm left with sine 60. Okay, so let's just remind ourselves. We have cos beta plus 80, not 180. Okay, it's just 80. And we have sine 60, so we can then use, you can change sine 60 and make it cos 30 because they are complementary. All right, so sine 60, you can check in your calculator. That will be equal to cos 30. So now we have cos 30 on the right hand side of the equation, and we have cos beta plus 80. And now, because I have the same trigonometric expression, I can then make the angles equal. So I have beta plus 80 is equal to 30 degrees. And in that case, I'm going to leave it at that. Then I'm going to try to get the general solution. Okay, so cos, where's cos positive? Cos is positive in the first and the fourth quadrant. So in the first quadrant, I'm going to say Q1. I know that beta plus 80 is basically equal to 30 degrees plus the period for cos and a sine function is 360. But for tan, it would be 180. Okay, and then we say k is an element of integer. So now beta would be 30 minus 80, which is negative 50 degrees, plus 360k. You don't have to keep writing that k is an element of integers. So we have then the general solution. Okay, but now we need to solve for beta. So if I were to say k is 1, let's just remind ourselves. So we're looking at values between negative 90 and 270. So where k is equal to 1, well, let's start at negative 1. Okay, we're going to have negative 50, negative 360. So that is outside of the domain. But if we choose k as 0, so k being equal to negative 1, that would work. But k being equal to 0, we get negative 50. Is it part of the domain? Yes, it is. Okay, so therefore beta is equal to negative 50. Now, if I said k is 1, that would be 360 minus 50. And that's 310. That's outside of the domain. So I'm not even going to bother looking at other values. Okay, so normally we do negative 1, 0, and 1. Outside of that, the values are too big. And an integer means that you can't have fractions. Okay, we're dealing with whole numbers. Now let's look at quadrant 4. I'm going to try to squeeze things in here. So I have beta plus 80 is equal to 360 minus our reference angle, which is 30, and then plus 360 times k, where k is an element of integer. All right, so I have beta plus 80, 360 minus 30, I have 330 plus 360 times k. And now beta would be 330 minus 80, 330 minus 80, maybe that's what, 250. Okay, so beta is 250 plus 360 times k. Now if I go with k negative 1, let's see, k is equal to -1, then what is beta? So I would have 250 minus 360. -110, no, it's outside. So that doesn't work. So beta cannot be equal to -110. If I have k is equal to 0, then I will have beta beta equal to 250. That is within the domain. Yes, it is. But if I were to have k is equal to 1, it'll definitely be outside of the domain. So we have our answers. Okay, what are the values for beta? Oh, they said without using the calculator. Okay, guys, we could have done those calculations, honestly, without the use of the calculator, okay? So beta is ultimately -50 degrees and 250 degrees. And where would the marks be allocated? Ooh, 7 marks. I think firstly, it's to recognize that your sine can be rewritten like this, and cos can be rewritten like that. So that's 2 marks, and maybe 3 and 4, and then 5 and 6, and then 7 getting the final thing. That's just my guess. Okay. So yeah, 3.3. All right, so it says determine the value of the following without the use of a calculator. So 3.3.1, we have sine 49 divided by cos 41. So before we even go far, I would ask myself, if I were to add 49 and 41, will I get 90? And yes, I would. I would get 90. So the two are complementary. So what I would then do, I would either change the sign or change the cos. It's really up to you. So I would say then sine 49 is just me taking, okay, sine 49 is me taking 90 and subtracting 41, all right? Cos, and this is 2 marks, okay, cos 41. So basically, the sine and the 90, we change it to a cos, and then we have 41, and it's in the first quadrant, so it's positive. All right, and that's just equal to 1. Marks, I think you would allocate them there. So now we have sine 85 multiplied by cos 60. So sine, cos, cos, sine. Okay, so I hope you see there the trend. Cos 85 times sine 65. Okay, so I have sine, cos, cos, sine. So that would be, and the angles are not the same. What did I, oh, I didn't write them correctly. Ooh. Guys, yeah, writing legibly, nah, that makes all the difference. So basically I have sine, and with sine, the sign remains the same. It's not like cos. And so we have sine 85 plus 65. All right, which is just basically, I'm going to check on the calculator. So 85 plus 65, that's 150. So that's sine 1. Okay, they said without the use of a calculator, but I get it. You can always check. They don't know. So yeah, that's 150. But can we reduce this? Yes, we can. So sine 180 minus 30. Okay, so we can reduce it, and we have sine 30. Okay, which is simply a half. And you can always check for yourself if this is really the case. So if I had sine 85 and I multiplied by cos 65, and I added cos 85 times sine 65, I should get a half. If I don't, and have to make sure that it's on degree, not radians, okay? What else things are wrong? Ooh, okay, so a half, we're good. We get those 3 marks. I think a mark for getting the answer, a mark for doing that and reaching sign 30. All right, and then 3.3. Wow, we're at the end. Oh, I'm enjoying this paper a bit more. The plan was for me to only do question 1 and 2 while my husband cooks. I was like, love, can I please do the paper? Please cook tonight. Oh, guys, the pods today are not potting for me. I'd rather do this than cook. So yeah. Okay, so now we have a half cos 15 plus root 3 sine 15. If I were to multiply back, let me multiply in this half. It looks suspicious. So I have a half cos 15 plus root 3 over 2 sine 15. Okay, my son is with me, so please, if you hear sounds of eating and blowing nose, I'm not alone. All right, so I know that a half is sine 30, okay, or cos 60. Yeah, let's see. I'll see which one I end up using. And then I have cos 15. And then square root 3 over 2 is cos 30, right? We can always make sure, we can always check that, yeah, so cos 30 or sine 60. Okay, I'm just going to write that there as an option. And then I'm going to multiply it by sine 15. So I have sine cos cos sine, or I can have cos cos sine sine. It's really up to you which one you choose. I'm just going to go with the sine cos cos sine. All right. So then I have sine 30 plus 15, which is sine 45. You can see the smile on my face. I can see sine 45. And sine 45, I think it's what? Is it 1? No, that's tan 45. So sine 45 is 1 over root 2. Ne? Yeah. Sine 45. 1 over root 2, which is root 2 over 2. Okay? For those who don't believe me, 1 over root 2 is root 2 over 2. Alrighty, and we are done with question 3. Wow, okay. Alrighty, bye.
Well, welcome to MV Tutors. My name is Figa Manana, and we're still doing the 2022 Gauteng examination, paper 2 now. We're now in question number 4, as you can see over here, question number 4. And it says, 4.1 says, determine, okay, let's just write 4.1 there. Determine the general solution of the following equation. They give us the equation and it's cos 54 minus x is equals to sine 2x. Now from this we can see that since we have two of these, we have cos and sine, it's probably going to be that one where you equate the things that are inside, if I can put it that way. The things that represent, or the variables and numbers that represent the degrees. Okay, and in order to do that, it's either we change this sign to become a cos, or we change this cos to become a sine. Every time you see a sine and a cos, remember there's a relationship between sine and cos. That is through co-ratios. Okay, now it looks like it will be much simpler to change the sign into a cos by saying cos 54 minus x is equals, now to change a sign into a cos, so I'm just gonna go ahead and write a cos. Remember, we have to introduce a co-ratio, and it's going to be 90 minus 2x. Okay, sine 2x is the same as cos 90 minus 2x. From there, now since we have causes on both sides, then that means the things that represent the degrees there are equal. We can therefore go ahead and say 54 minus x is equals to 90 minus 2x. Now, these are just, if I can put it this way, this is just the reference angle, because remember, we always start with reference angle, and then we introduce which quadrants we're working with. Now, where is cos positive in? Cos is positive in the first quadrant and also on the fourth quadrant. Right. So let's start with the first quadrant. Okay, the first quad. In the first quad, I mean, the angle is just equals to the reference angle. Okay, so 45 minus x is equals to the reference angle, which is 90 minus 2x plus k 360 or 360k. Okay, and then you have to define k that it's an element of an integer, right? And then we do the gymnastics. So I'm going to take the 2x, bring it this side, it becomes positive. Then I have minus x plus 2x, which gives me x. This side, I want a number, 90 minus, okay, so I'm going to take 90 minus 45 because I take that 45 to the other side. And what's 90 minus 45? Let's get a calculator. So we say 90 minus 54. I keep saying 45. It's 36. Okay, so this side we have 36 plus 360k, okay, 360. Okay, so that's our first answer in the first quadrant. We now have to go and work with the second quadrant. Okay, oh no, the fourth quadrant. I'm not paying attention. The fourth quad. Now, in the fourth quadrant, okay, remember in the fourth quadrant, it's either we say we take the reference angle and we say it's 360 minus the reference angle, or you just take the negative of that reference angle. So let's do that one actually. So it's gonna be negative. Now you need to be careful because you need to put the brackets in. Otherwise your answer will not be correct. Because remember, that's the reference angle. That whole thing is the reference angle. Okay, this whole thing is the reference angle. So you have to put it in brackets and subtract it, put the negative. This allows us to then say minus 90, and a minus gives us a positive 2x plus k 360. Okay, now if you had not put these brackets, this 2x would have remained negative, which would have made your answer wrong. Now if I bring this 2x to the other side, I get minus 3x is equals to minus 90 minus 45, 54. I don't know why I keep saying it incorrectly. Okay, let's get a calculator. First of all, let us start with, so I have minus 3x here is equals to, we need to negative 90 minus 54. We get minus 144 plus k 360. Right, now when you divide everything by minus 3, remember that you also have to divide the K360 with minus 3. Everything gets divided. So that here I'm left with X. A minus and a minus becomes a positive, so we're just gonna divide by negative 3. We get 45 and it's positive. But this side, I have a minus, so it's a minus K 360 divided by 3, and we get 120. So it's K 120. Now, this is a interesting part that, remember the graph of, this is a coarse graph. It oscillates like that, right? So it doesn't matter if you are here, whether you go minus 120 or you go plus 120, it's the same thing, really. Okay, so we can actually change this minus and make it a plus, because remember, when it comes to values of K, you can put any number, any integer number there. Okay, you can put any integer. Actually, we should define it here that K is an element of an integer. You can put any integer number, whether it's minus 1 or minus 10 or plus 1 or plus 10, it's gonna work. So putting a plus in that standard form is much better. It shows more understanding than leaving it as a minus. So those are two answers. We have now answered question number 4.1. 6 marks. I'll circle back at the end where I tell you where the marks actually are. Okay, so we're in question number 4.2 now. Go. If 13 that and X is an element between 0 and 270, determine without the use of a calculator the value of sine 2x. Okay, so whenever they give you these things like 13 sine x plus 5 equals to 0, now that gives you a clue that you should probably complete a triangle. Okay, so we're going to do just that. So sine x is therefore equals, if I do the gymnastics, I take this 5 to the other side, it becomes minus 5 divided by 13. Now, to draw this triangle, I need to determine where is sine x negative. Okay, it's negative in this quadrant and that quadrant. But remember, they told us that x is between 0 and 270. Okay, so we know it's 270 down there. So between 0, so it's there, there, and there. Okay, we've got 2 ticks on this quadrant, which means our triangle should be completed on that quadrant. Okay, so we're gonna do just that. Okay, I'm not happy with that part. Just gonna put it up there. Okay, so our triangle then is on this quadrant, so if I complete it, it's gonna be like there. And sine is opposite over hypotenuse, right? So that's x there. Opposite is here and opposite is 5. So it's a negative 5 because we're on the negative side here. Okay, so a negative 5 down there. Okay, and then the hypotenuse is 13. Now, to complete this one, to get the value of that, we have to complete Pythagoras. And to do that, it's just going to be square root of 13 squared because it's the hypotenuse, and we subtract the 5 squared. Let me put it as negative. It really doesn't make a difference because anything squared is still going to be positive. Okay, so square root 13 squared minus 5 squared. What do we get? 12. We get 12. Now, this 12 is actually negative because it's on the negative side. All right. Now, they said, what's the value of sine 2x? Okay, let's just complete that. So that's our triangle. They want sine 2x. Now, this is now a double angle. Let's go check a formula sheet. We're given a double angle. There it is down there. Sine 2x is also equals to, if we check it out here, it's going to be equals to 2 sine x cos x, right? So just to complete that, it's 2. What's sine x? Sine x is opposite, which is minus 5, over the hypotenuse, which is 13. And what's cos x? Cos x is adjacent, which is minus 12 over a hypotenuse, which is 13. All right? So that's the thing we put in the calculator. It's 2. I want to put it exactly like that. So I've got minus 5 on top. The bottom, I got 13. Move to the side, close your bracket, open another one, another fraction. It's minus 12 this time. Go downstairs, put a 13, close the bracket. Now, I know what some of you are saying. The question said without a calculator. We could still do it without a calculator because it's just going to be 2 times 5, which is 10. 10 times 12, 120. Right? The negatives cancel each other. And then 13 times 13 is just 169. You leave it like that. That's your final answer. Okay, so now we are in 4.3. And it says prove the following identity. Let me just write it down. It's 1 plus sine 2x divided by cos 2x is equals to cos x plus sine x divided by cos x minus sine x. Now, if both sides are not simplified like this side, like this question, it means you can take either of them to prove the other. Either you take the left-hand side or the right-hand side. Both of them can work. So let's take the normal one, the left-hand side. Okay, left-hand side. So in the left-hand side, well, the first obvious thing to do is to do an expansion. Okay, so 1 remains as 1 plus sine 2x, we already know it's 2 sine x cos x. All right, now the cos 2x is a bit of a tricky one because it has 3 solutions. If you look down here, this double angle, of course, it has 3. Now, how do you know which one to pick? Okay, sometimes it's easy to tell, but sometimes it's not. Okay, it just takes a trained eye to know which one to use. Now, I'm going to use this one with a vision in mind. This first one, cos squared x minus sine squared x. And the reason I'm going to do that is because I want to change this one. Okay, that one is going to change to the identity as well, the square identity, which is cos squared x plus sine squared x. Remember, cos squared x plus sine squared x x equals to 1. So I've just done that. Plus 2 sine, everything else remains the same. Okay, so this one remains exactly as it is. Now what I'm going to do is I'm just going to rearrange it so that it looks like a formal. So I'm gonna start with the cos squared x, and instead of writing sine squared x, I'm gonna write plus 2 sine x cos x. So all I did is just take this part and bring it in the middle, and then I can write the plus sine squared x. Now this looks like I can factorize it real well. Okay, I'm leaving this one exactly as it is, right? Minus sine squared x. So what this then allows me to do is that if I look at the top, factorizing this one, this is really cos x plus sine x times cos x plus sine x. If I multiply this out and expand it, it will become exactly that. Okay, divided by, also I can expand the bottom one. Now the bottom one is a difference of 2 squares, so it becomes cos x plus sine x, but at the bottom now it becomes cos x minus sine x. Okay, I hope you see what's going to happen now. That is going to cancel that, and then I'm left with the right hand side, which is cos x plus sine x divided by cos x minus sine x, which is equals to the right hand side. So let's change this to r hand side. That's it. Okay, so let's do question 4.4 now. All right, so it says if sine that is equals to p, determine the following in terms of p. Now, whenever you see these questions, you must always know you will have to draw a triangle. Okay, so we are given sine 39 is equals to p. All right, so let's go quadrant. Which quadrant is this triangle going to be in? It's either this one or that one. Okay, now is there any other information that we have? No. So okay, let's draw it on the first one. Okay, let's just draw a simple triangle. Just a simple triangle like that. So that's gonna be 39 there. And sine is really opposite over hypotenuse. What's our hypotenuse, you ask? It's just 1. So the opposite is p and the hypotenuse is 1. Okay, always just introduce a 1 there. And then this one we'll do Pythagoras once again. It's going to be 1 squared, which is just 1, minus p squared. Okay, 1 squared is 1, so we don't have to put the square there, but we can in theory. Okay, so now 4.4.1 says calculate sine 129. Now we have to rewrite 129 in terms of reduction formulae. Okay, and we have to use 39. We have to use 39. but just by looking at it, if I say 180 minus 39, will that give me, oh, that gives me 141. So it doesn't work out. Now let's try 90 plus. If I say 90 plus 39, will that work out? Exactly. So 129. So I can say 90 plus 39. I have to use 39 in all my reduction formula or co-ratios because it's the triangle that I drew. So this, remember, a 90 changes a sign to a cos. So this is just cos, and sine is positive in this quadrant. So in quadrant 2, because 90 is there, plus, which means it's in this quadrant, and sine happens to be positive, so cos is positive as well. So drop the 90 now, because we've already changed a sine into a cos, and then 39. So this is just the same as saying what's cos of 39. So cos of 39 we know is adjacent of a hypotenuse. Adjacent is 1 minus p squared. So that's your final answer. Okay, thank you, calculator. Let's go to the next question, which is 4.4.2, and we have 10, 3, 2, 1. Now we need to rewrite 3 to 1 in terms of our reduction formula. Let's see. If we say 360 minus 39, 3 to 1. Cool. So let's use 360 then. 360 minus 39. We have to use 39 because that's the triangle we have. Now, which quadrant is this in? This is in the fourth quadrant, and 10 is negative in the fourth quadrant. So this is negative 10. Okay. This is negative 10, 39. Cool. So whatever 10 is going to be negative. So when you go back to our triangle, remember 10 is opposite TOA from SOHCAHTOA. It's opposite over adjacent, so it's P over, let's rewrite this, it's P over the square root of 1 minus P squared. Cool, that's it. Thank you, calculator. You may leave. Let's go for 4.4.3 now. We have sine 78. We have to rewrite 78. Now, if I say 90 minus 39, that will not give me 78. It gives me 51. The only way I can get 78 is if I say 39 times 2. So this becomes a double angle now. It becomes sine 2 times 39. Remember, with all of these manipulations, they must all have 39. This is a double angle now, and remember, when we expand our double angle, it becomes 2 sine, the angle is 39, cos 39. Okay, so then it becomes 2. What was sine 39? Did we solve it? Sine 39. Okay, let's look at our triangle. It's opposite, which is P over 1. So we just write a P there. All right. And then our cos 39. Cos 39. There, we solved it here. It's that square root. Square root of 1 minus P squared. Okay. So that's our answer. Just get rid of the brackets, and then I have 2p square root of 1 minus p squared. Stays like that. Well, That's the final question. Let me just circle back. Let's do the marks. Okay, let's do the marks. 4.1 was a 6-mark question. First mark is to expand this co-ratio, 1 mark. Reference angle, 2 marks. Working with the first quadrant, and the answer there, 3. Fourth mark is this. Expansion working with the fourth quadrant. Fifth mark is that, dividing everything by 3. No, actually the 6 marks. 6 marks is just the answer. There we go. And then let's come to 4.2. 4.2 is 5 marks. Yes, the first mark is for the diagram. Second mark, expanding this, recognizing this expansion. And then the correct sine x, the correct. So that's 4, that makes it 4 marks. And then the 5th mark is the answer. 4.3, the first mark is expanding this thing. The second mark, it's out of 7 marks. Second mark is writing this. Third mark, that, changing 1 into this identity, the square identity. Okay, 1, 2, 3. Fourth mark is actually this part of simplifying. Okay, first of all, expanding. So it's expanding. I give you a mark for expanding this, like that. How many marks do we have now? 1, 2, 3, 4, 5. And then the 6th mark is also expanding these two. 7th mark is doing the cancellation. Okay, these cancellation makes it 7 marks. The next one, 4.4.1 is 3 marks. So the first mark is always a diagram. It's always a marks for diagrams. And then the second mark is changing the sign, recognizing that it's cos 39. The third one is the answer. 4.4.2 is 2 marks. First mark is recognizing the 10 is 39 and it's negative. Second mark is the answer. 4.4.3 is 2 marks. Well, the first mark, this question should have actually been 3 marks because the first mark is expanding the thing, and then the second mark is the answer. That's it. I hope you understood everything. Please like and subscribe our channel. We would really appreciate it, and I personally appreciate you. Well, welcome to MV Tutors. My name is Firagasha Manana, and we're still doing the 2022 June examination for Gauteng province. Okay, we're doing paper 2, and we're now in question number 5. Let's read the question. It says in the diagram below, O is the center of the circle, and L is a point on the circumference. I see it. The diameter PQ makes an angle. Okay, so PQ is the diameter of 26 with the tangent RLM. N is a point on the lower part of the circle. Now, with these types of questions, I like to do what I call Dr. Cape Town. Well, I don't call it, I found it there. Dr. CPT. CPT stands for Cape Town. And what I do is that I go to the statements and I tick what I'm given in the statement. So, for example, am I given a diameter? Does the statement give me a diameter? Yes, it does. Does it have a radius? Yes. If there's a diameter, there's a radius too. Does it have a cyclic quad? Am I told anything about a cyclic quad? No. What about parallel lines? Am I given parallel lines? No. What about a tangent? Yes, given a tangent. From here, then, I have to then say, okay, what are the rules of diameter? What are the rules of radius? And then what are the rules of the tangent? That is what I'll be using to answer all the questions. Okay, so let's get right into it. Let's look at 5.1.1. They want OLM. Now, OL, that's what? The radius. Okay, M is the tangent. Now, what do we know about the radius and the tangent? Okay, we know that they are perpendicular to each other. So I can then say, conclude that OLM, the angle OLM is equals to 90 degrees. And the reason is because I know that the radius is perpendicular to the tangent. Yeah, that's it. Stop it. What's going on? That's it. Come on. Stop that. Tangent. Okay. Now let's look at the next question, which is 5.1.2. It says O2. Now O2, let's look at O2. What is O2? I can see now another thing they do with these questions is that the previous question leads into the next question, which means this answer should give me a clue of what I should do on the next question. Now, how does this answer help me answer the next question, which is O2? Now, if we look at O2, it's right there. And if we look at triangle O, L, M, I'm looking at the triangle now specifically. Okay, I can see that O2 is there and L I have and M I have. So if I say O2 plus that's angle, yeah, O, L, M that I just solved plus the angle of M, that is going to give me 180. And the reason is, you guessed it, sum of angles in a triangle. Sum of angles in triangle. Okay, so I can then go ahead and put numbers. OLM, I've solved it to be 90 plus M is given to be 26. That's all equals to 180. So O2, therefore, O2 will be equals to 180 minus 90 minus 26, which would give me, let's bring out the calculator, 180 minus 90 minus 26. That gives me 64. Okay, so that's it. O2 is just 64. All right. Now let's look at the next one. How does O2 help me in solving the next question, which is angle P? There's angle P there. Now, if you look at O2 and then you look at P, you can see that they're subtended from the same chord, which is LQ. Okay, which means the relationship between O2 and P is that of, you remember it? This one. So I can say O2 is equals to twice the angle of P, and the reason is, what is it? angle at center is equals to 2 times the angle at circumference. Okay, that's it. So now I can go ahead. My O2, I solved it to be 64 is equals to 2p, doing gymnastics. So dividing both sides by 2, therefore p is equals to, let's get a calculator, 64 divided by 2, 32. Thank you, calculator. 32. Okay, right. It's important to put degrees. Let's just put degrees and be consistent, please. Let's put degrees. Okay, I already put them there. Okay, now how does P help us to solve the next one, which is 5.1.4, and they want Q1. Let's check it out. Okay, so if you look at triangle PLQ, Q1 is there. So we're looking at triangle PLQ. That's what we're working with. In triangle PLQ, we can say, first of all, PLQ, that angle PLQ is equals to 90, and angle at semicircle or you can say, if you want to use diameter, angle subtended by diameter. It's always going to be 90. The angle subtended by diameter is always going to be 90. Now, we have the value of P, which you solved it, is 32. So in that triangle, we can say P plus that angle PLQ, right, plus Q1, which is what we're looking for, is equals to 180. And the reason is, what's the reason? That is correct. You said it correct. If you said it's sum of angles in a triangle, right? Just like that. Okay, so P, we've solved it to be 32 degrees plus PLQ, we've solved it to be 90 plus Q1 is equals to 180. We do some gymnastics there. Then Q1 is equals to 180 minus 90 minus 32. Okay, we need your services calculator. We go 180 minus 90 minus 32, and we get 58. Okay, so Q1 is equals to 58 degrees. That's it. Okay, let's look at question 5.2 now. So 5.2, it says, in the diagram below, the points A, B, C, and D lie on the circumference of a circle. So A, B, C, D, that's a cyclic quad because it's inside a cyclic. All right. So they say prove that C2 over there is equals to B minus A. Okay, so using Dr. Capetown, we can see that we have a cyclic quad. Okay, so what do we know about a cyclic quad? We know the external, that's the first one, that opposite angles are supplementary, but also the external angle is equals to the internal opposite. So let's use D1. Okay, so let's start there. Let's say D1 is equals to B, and the reason is external angle of a cyclic quad. Right. Okay. Now we have that D1 is equals to B. Now what else can we do? If you look at C2, C2 is actually positioned inside a triangle ADC. If we look at triangle ADC, let me just say in triangle ADC, we can see that actually D1 is equals to A1 plus C2. And the reason is external angles of a triangle. External angle of a triangle. Remember that rule, external angle of a triangle, D1 is equals to A1 plus C2. So now we can just do gymnastics by making C2 the subject of the formula. So C2 is equals to D1 minus A1. But we've already said that D1 is equals to B. That's proven, right? So what that means is that where we have D1, so C2 is equals to, where we have D1, we substitute B. So it's B minus A1. And there we go. It has been proven. That's it. Let's now do the mark allocation. Okay, mark allocation. First one was 2 marks, so you get a mark for 90 and the reason. Okay, second one was 1 mark. Oh wow, that was not fair to give you 1 mark for the second one. It's just for, you know, everything. Wow. Wow. I cannot believe it. I'm just as shocked as you. 5.3. It's 2 marks, so you get a mark for the answer and the reason as well. 5.1.4, it's out of 3 marks, so the first mark is yes, the answer and these reasons. Okay, so that's the 3 marks. 5.2, let's go to 5.2. 5.2 was 5 marks. Okay, let's find the marks. So first mark, that reason with the statement. Okay, second mark is the reason, the statement and the reason, and then the final mark is the answer, of course. Then I think that's it. Well, that's just it. Thank you so much for tuning in. I appreciate you so much. Please do like and subscribe on our channel. Welcome to MV Tutors. My name is Fikakahle Manana, and we're still doing the 2023 June examination in Gauteng, and this is mathematics paper number 2. Okay, so we're now in question number 6, and here it goes. It says, we read here, in the diagram below, O is the center of the circle. Okay, I see O. And A, P, and B are points on the circumference of the circle. Arc AB subtends AOB. Okay, I see that. At the center of the circle, and APB at the circumference of the circle. Cool. Now, use the diagram to prove the theorem which states that AOB, so that's the angle at center, is equals to twice the angle at the circumference. All right, now the first thing that you want to do, this is a proof. Okay, so the first thing you want to do is make a construction. Okay, so you'll get a ruler, and then with your ruler, let's just draw some lines. Let's change that to purple. Let's draw a line. Let's join. Let's construct. Let's just construct a, that line there. Okay, thank you, ruler. And then we'll have O1 there, O2 there, and then we'll have P1 there and P2 there. So basically what we just did is basically just bisect the angle at the bottom, at the center, and also bisect the angle at the circumference. Okay, so let me just that's a construction. So we construct OP. Cool. Now what we can see now is that actually if you look at OP, it's equals to OA. And why is that? Because they are both radii. Okay, so that's the reason. They are both radii. Now, being both radii, we can also see that actually P1 is equals to A because of equal angles, equal sides. All right, because they're both radii. So we can conclude then, because since the sides are equal, it means the angles are also equal. So then we can say P1 is equals to A, and the reason is equal sides, or equal angles rather. Let me start with angles. I prefer starting with angles for this one. Equal angles, equal sides. So that's how you write that reasoning there. It's acceptable. Now, since P1 is equals to A, that comes from these two, the sides being radii. Now, if we look at this triangle over here, AOP, we can see that actually O1 is an external angle. And how do we get an external angle? We add the internal opposite angles, the internal, so which means A plus P1 is equals to O1. Now let's write that actually. So I'm saying O1 is equals to A plus P1. But we've already proven that actually A is equals to P1. So we can actually substitute, where there's an A, we substitute P1. So P1 plus P1. P1 plus P1. So O1 is equals to 2P1. Okay, so we've just proven that O1 is twice P1. So we can also conclude that similarly, or let me just write, similarly, O2 is equals to twice P2. If you want to prove that, you can do, but you'd have to follow these exact steps. So I don't want to redo that. Now that I've proved that O1 is twice P1 and O2 is twice P2, if I say O1 plus O2, and the reason I'm saying that is because it forms that angle of AOB. It's O1 plus O2 from our construction, as you can see there. All right, so that's equals to O1 is equals to 2P1 and O2 is equals to 2 P2, and we can take out the common factor, which is 2. So that's 2P1 plus P2. Okay, therefore, remember, O1 plus O2 is equals to A, O, B is equals to twice, because P1 plus P2, they form A, P, B. That's it. That's how you get your final marks. Okay, we're in 6.2 now. It says in the diagram below, F is the center of the circle. Where's F? There it is. And AC is a diameter. Cool. AC produced to K, that means produce means it's a straight line, 180 degrees at C. Produced to Ka, B1 plus B2 equals 122, and K is 26. So they say show that BK is a tangent to the circle. Okay, what we have to do now, the game plan is to show that BK is a tangent. We have to show that this angle right there, okay, is equals to the internal opposite angle, that one. If we can do that, then we would have proved that that is a tangent. Okay, now let's see, where can we start? Right, now what we know, we have been given that this, let's solve B2. In order to solve B2, we need to know B1. So what do we know about B1? And let me just highlight, look at this triangle, A, B, C. Okay, now what do we know about this? We know that any angle subtended by a diameter is 90. So we can go ahead and say B2, sorry, B1, not B2, B1. We can go ahead and say B1 is equals to 90 degrees, and the reason, or we can just say an angle at semicircle. So angle at semicircle or angle subtended by diameter, any of those work. Okay, it's 90. Therefore, B2 is equals to that 122 that we are given. 122 minus B1, which is 90. Okay, now if we put that in a calculator, 122 minus 90, we get 32. Okay, so we know B2 is 32. Okay, now we need to solve A. What can we do with A? Now, if we look at a different triangle this time, let's change its color. Let's go cyan. If we look at this triangle now, A, B, K, right? We're looking at this triangle. From this triangle, we can see we have the angle of B there, which is 122. We have the angle of A, which is 26, which is, the angle of K. We need to solve the angle of A. So this is a full triangle, and we know angles in a triangle. So the statement is A plus A, B, K, right, plus K is equals to 180. And the reason for that, sum of angles in a triangle. Okay, so let's go ahead and put numbers. A is what we're looking for. ABK we are given, it's 122. plus k we are given, it's 26. All of this is equals to 180. Need to do a bit of gymnastics to solve for a. It's going to be 180. Take this to the other side. 22 minus 26. And then what do we get for a? Let's see what the calculator says. So it's 180 minus 122 minus 26. And we get 32. Look at that. We've just proved that B2 is equals B2 is equals to A, which are both equals to 32. Therefore, what was the statement? BK is a tangent. And so we call this the converse 10-chord theorem. 10-chord. Okay, 10-chord theorem. That's it. Okay, so we're just gonna quickly do the marks. This was 5 marks. First mark is the construction of that line OP. Okay, that's the first mark. Second mark is recognizing that these are radii. That statement and its reason. Fourth mark is recognizing that, third mark is recognizing that with this reason, equal angles, equal sides. And then the fourth mark is this, O1, proving that. And then the fifth mark would then be the conclusion. Okay. Good. Let's move on to the next question. Now, this question was worth 5 marks as well. So, first mark is recognizing P1 and its reason, statement and reason. Second mark, solving P2. Third mark, this and its reason. Fourth mark, recognizing A or solving A. And then the last mark, the fifth mark, is the conclusion, especially with the reasoning. Well, ladies and gentlemen, that's it for today. Thank you so much for tuning in. Please like and subscribe on our channel, and I appreciate you. Well, welcome to MV Tutors. My name is Firagashe Manana, and we're still doing the Gauteng paper, provincial paper for June 2023, and we're still on paper 2, and we are now on question number 7. Okay, let's get right into it. It says, let's just read it together right over here. In ABC below, ABC, okay, D and E are points on AB and AC respectively. Okay, I see them, such that DE is parallel to BC is shown. Okay, prove the theorem which states that AD over DB is equals to AE over EC. Okay, now before we do this, there's certain things that I need to remind you. First of all, the first thing is that the area of a triangle is half base times the perpendicular height. Okay, the height has to be perpendicular. For example, if you have an acute triangle, then this will be your base, and then the height, if that's your base, this is your height right there, right? But also, even if it's an obtuse triangle, let's say you have an obtuse triangle like this, right? the base is still that, but the height now, it still has to be a perpendicular height. So the height starts from that apex to there. That's the height. It's outside the triangle, but it's the height you use. It's a perpendicular height. Those are the two triangles that we will use in this question. And so the first thing that we want to do then is actually construct these heights. Let's start with the heights. Let's start with this one. I will call it the green height. And the green height, and it's perpendicular, right? Let's call it H. And then let's also construct a red height. Or maybe let's just work with this one first, and then we'll circle back. Okay, so now using this height, we're going to say the area of triangle, the big triangle, the small triangle ADE. Okay, of triangle ADE. And we're gonna divide that with the area of triangle. Now, I want to construct, what I want to do is construct this triangle, right? This obtuse triangle. And I'm gonna call it BDE, which means I need to construct again. Construct this line. This line called, it's not a very neat construction, but you see what's going on here. Okay, basically I'm just trying to create this triangle here, which is an obtuse triangle right there. Okay, so that one is BDE. BDE. Okay, so the areas. So we're gonna say half. Let's start with ADE. Half base, and the base, what's the base? The base, now if you look at here, the base of this height is actually AD. It can only be AD, the base of this height. You can't use any other height, because if you want to use this height of DE, then if you want to use this base of DE, then you have to construct a new height there, but a perpendicular height. But the base of this height that we constructed is AD. So we're gonna write half. It's gonna be half, right? Times DA. Sorry about my D looking like funny like that. And then the height is H. Okay. Divided by a half times, when it comes to this one, as you can see, the height is the same, but the base, it can only be DB, right? So we're gonna put DB times that same height. So what happens here is that half cancels with that half, that height cancels with that height, and I'm left with DA or AD over DB or DB. Cool. Now we're done with that part. Let's now go red. So we're gonna construct a height. There we go. Right there. We're gonna name this one K. Right? And then also gonna construct this, right? This triangle here. All right, we are now working. Let me just rub this one because we're done with it. We are now working with this triangle, DEC, that triangle. That's going to be our obtuse triangle that we're working with. Okay, using this height. Now, we're going to go for the same thing, area of triangle ADE, same triangle, just different height, all over area of triangle. This time it's triangle CDE. CDE, right? Okay, so let's start with ADE. It's half times. Now, if you look at this height that we constructed, can only have a base of AE. Okay, so let's do that. Let's write that. So it's AE times the height, we called it K. Now let's go to that other triangle, CDE. It's half, and the base, it can only be EC, right? So we got EC times the height of K, because it's a triangle like that, that perpendicular height is K. Once again, these two cancel each other. And then I'm left with AE over EC. From there, we need to realize that, but actually, if you look at these two triangles that we constructed, these two triangles, these DEC and BDE, okay, they are actually equal, okay, but triangle and these bottom triangles, let's write this one down, BDE is equals to triangle, this one now, CDE. And the reason is they have the same base, and also the height is basically the same. Okay, obviously ADE, let me just write it for you. Also the top ones, triangle ADE is common, right? So ADE is common. So once we've realized that ADE is common and the bottom triangles, the top triangles are common in the fraction, and also the bottom triangles are similar, then we can literally equate to them. Okay, now that we've determined that you know, the bottom triangles are equal and the common triangles are the top ones in the fractions, we can now make the statement that the area, okay, of triangle, we'll just take this top part and make it equals. That's exactly what it means. So I'm just gonna rewrite that, ADE over the area of triangle BDE is equals to this bottom one, the red one. Okay, it's equals to the area of ADE over the area of CDE. Now, remember when we did the cancellations, when we did the areas, the individual areas, we got that green one gave us AD over dB, and that's equals to the red one, which gave us AE over EC. That's it. We are now in question 7.2, and it says in triangle DXZ below, DXZ, all right, AC is parallel to XZ. Where is that? AC, okay, I see them. And BP is parallel DZ. See them? It's drawn to intersect AC at B. Now prove that. Okay, so what I like to do with these types of questions is that it says BC. So I want to highlight BC. Where is BC? BC is over there. That's the first thing I do. Over YZ. Where's YZ? YZ is there. And then DA. DA is that. Oh, my bad. DA is this one. Highlight that over DX. Okay, so DX would be this long one. Okay, so now I can kind of see that, all right, looking at DA over DX, that would be my starting point, right? I would want to start there because it looks like it's more defined. All right, it's more defined. This one, not so much. BC over YZ. So let me just pause there. So even if I don't know what to do, the first thing then I would do is I would say in triangle, let's work with DXY. In triangle DXY. Okay, so what can we see in triangle DXY? Now, the question has DA, which is this small one. DA, let's do it like that, all over DX, which is the longer length, DX. So we got the right hand side. Okay, that is equals to, if we just take those two, that's equals to DY, the longer one. Oh, okay, no, DB, because we start with the smaller one. It's equals to DB all over dy. Now, let me just pause there to say that I know you asking yourself, why did I use dB over dy? Or rather, why did I use the triangle dxy when I could have used dxz? Now, here's the thing. This is exactly why you need to practice more in mathematics, because the more you practice is the more you learn the tricks of the trade, rather, the tricks that they try to trick you with in the exam questions. Okay, and the more you learn their tricks is the more you learn how to navigate them, how to solve them, how to see through the trickery. Okay, so now what we are trying to do here is that they gave us these parallel lines. Okay, AC parallel XZ. So that's the one we are using. So the game plan here, just so that you know, let me use this, is that we are going to use, because if you look at this panel here, let me highlight it rather. If you look at this panel here, dB over dy, that panel is also common on both on both parallel lines, because, let me rub everything so that it's clear. DB using these parallel lines. Okay, DB is in this triangle, and that triangle uses these parallel lines, which is that parallel line and that parallel line, right? Now, the same DB, okay, if I highlight it, using the other parallel lines in this triangle, you see that these are the parallel lines. Okay, so that's why I'm using DB as a common space. So what I'm gonna do now, let me just rub this. What I'm gonna do is that I'm gonna say in triangle. Now I'm gonna look at the other triangle. This time in triangle DYZ. In triangle DYZ, which is in fact this triangle, right? Now I'm gonna start with the same DB over DB over DY. Okay, it's the same one from the top one, which is continuing, but in this triangle, what is it giving us? DB corresponds with ZP, if you can see that. ZP is proportional to that. And then dy, that long one, corresponds to dy corresponds to zy. You can see that. Okay, now I forgot to put the reasoning. The reasoning for this, it's the proportional theorem, yes, but you also need to name the parallel lines. The parallel lines for this proportional theorem is this one, the top one, which is BP. Well, let me write it like they gave it to us. BP is parallel to DZ. That's the reason for there. But here, the reason here is also the prop theorem. Okay, and the parallel lines here was AC is parallel to XZ. Cool. All right, now that we have equated these two, you can kind of see now where I'm going with this. You can see that, okay, let me equate these two. That, okay, therefore dA over dx is equals to dB over dy, which is also equals to ZP over ZY. What did I just do? I just equated all of these. Okay, I started with that, I moved to there, and then this and that are exactly the same, so I just moved to that, equate them all. Right, now if we look back at the question, it has dA over dx. Okay, we have that, dA over dx, and then it has BC over YZ. Now, if you look at what's going on here, okay, we have this dA there, we have this dx there, I'm going with the question, and then we have this BC rather, and the YZ. Okay, cool. Which are that? That's what we just took the BC over that. But now I want you to look closely here. The one that's not common is this BC. Okay, and for BC we have ZP. Everything else is the same. That DA is the same there, DX is the same there, that ZY is the same. The only thing is ZP and BC. Now we need to look at the relationship between BC and ZP. Let's see if we can find a relationship between what is it? Let me highlight it. ZP or PZ, which is that, and BC. What's the relationship? They must be the same because it's a parallelogram. Do you see that? It's a parallelogram. All right. So here, I actually have to make a statement before I make this conclusion to say, but ZP is equals to BC, and the reason is equal sides of a parallelogram, which is they are equal sides of a parallelogram. We can write it as a palm parallelogram. That stands for parallelogram. Okay, so now that we've made this statement, then this one then is all correct. It's all we can make this conclusion. As a matter of fact, we can actually make that conclusion, rewrite it as they wrote it in the question, as BC over YZ. I'm just rearranging. I'm starting with this side. Is equals to DA over DX. That's it. Well, I know this one was a mouthful. It was pretty tough, but I really hope you understood what I was trying to explain there. Okay, let's do the marks. So, 1 mark for construction, right? This one is a 6 mark. 2nd mark for doing that. 3rd mark for doing that. 4th mark for realizing that. And then a final mark for equating these. That's 6 marks. Is that 6? 1, 2, 3, 4, 5. Oh, there's one more mark. Okay, so, right, making a conclusion. And then the next question, man, I did it so far, I didn't realize. This is a 5-mark question. 1 mark for all of this, 2nd mark for all of that. 3rd mark for this statement. 4th mark for that. There should be 2 more marks here. Okay, so I give you 1 more mark for that. 5 marks. Okay, well, that's it. I appreciate you. Please like and subscribe on our channel, and that would be really great. Goodbye. Well, welcome to MV Tutors. My name is Fiagahle Manana, and we're still doing the 2023 June examination. This is for mathematics, the Gauteng province specifically. We are now in question number 8. Let's get right into it. It says, in the diagram below, NPQR is a cyclic quadrilateral with S, a point on chord PR. Okay, I see that. N and S are joined, and R and S is equals to P and Q, which is equals to X. I can see them. There they are, right there. Now it says prove that these triangles are congruent. So when they put it like this, to you, it's what they mean is that, okay, is that actually the triangles, these angles are put in order. Okay, these angles are put in order such that this n must be equals to that n, and then that s must be equals to that p, and then that r in turn must be equals to that q. That's how it's done. That's what we have to prove. Now, secondly, I like to actually highlight the triangles that I'm working with. Okay, so let me start with this one. NSR. NSR. So it's this triangle. Let me just complete it. There we go. And then the other triangle, which I will highlight, is NPQ. So it's NPQ. It's that triangle. Right. So these are the two triangles that I'm working with. So what I'm going to do, I'm going to start with the n to prove that this n is equals to that n. Can I prove it? Yes. And they are given. So I can say R n s is equals to Q n p. And the reason is it's given as x, right? Now, the second one, I'll go to the second angle. Can I prove that S, which is S1, is equals to P, which is this whole P? Well, it looks like a bit of a challenge. There's no way that I can prove that at this point. So I don't want to waste time. I'm just going to move on to the next angle. So I'll move on to the next angle and see if it would be easier to solve that one. What about this R? This is R is R1. Can I prove that R1 is equals to this Q, which in this triangle is Q2? Can I prove that R1 is equals to Q2? Well, what I'd like to do over here, just to show it to you nicely, is that if you look at this chord right here, this chord of NP, you can see that actually that chord is subtending the R1 that I'm looking for, right? It subtends there. It also subtends to the Q2 that I'm looking for. So therefore, I can conclude then that actually R1 is equals to Q2. And the reason is same chord, or same segment. Let me say same seg, and you must name the segment. It's the chord NP, right? Now, these ones that I couldn't prove, they just become the third angle in a triangle, as you know some of angles in a triangle. So in this one, it's the S1. And then this side, I'm just going to name it in long, which is NPQ. NP gets a cap Q. So I'm just gonna say third angle in a triangle. Right. Now I need to conclude. Now, when I conclude, I rewrite that statement again of congruency, that I've now proved successfully that NSR in this order is congruent to NPQ. Remember, congruent means exactly the same. Now, there is a mark for writing this part, angle, angle, angle. If you don't write that part, you lose a mark. So make sure you include it. But we'll circle back at the end to come and show you where the marks actually are in this question. All right, that's it. Okay, let's look at the next question now, 8.2, still congruency. So let me write it down first. So we are looking at triangle NQR incongruent to triangle NPS. So basically, like we said before, we have to prove that this N and that N are the same, that Q is equals to that P, and then finally the R, this R is equals to that S. Cool. Now let's highlight our triangles. N, Q, where's Q? Okay, so it's N, Q, and R. Okay, highlighters are very important when it comes to this topic, because you got to visualize and see these triangles that you're working with. The next one is NPS. NPS. So this triangle right there. Okay. Now let's see, can we prove these ends? Rn, yes. Starting with the ends, we can prove that the angle RNQ is equals to the other one, which is SNP. All right, P, not R. Why did I write R? I mean P. Okay, and the reason these are equal is because we have been given that you can see this axis, and that's a common angle, but we know that R and S is equals to P and Q, which are both equals to X. So you can put this in as a reason, but don't say given, because you are not given. We are given X for these angles, these ends, but for these ones that we are trying to prove, we're not given. So we use what we have been given to prove what we are not given. Because of that common angle there, actually, let's just include it to make sure that we write everything in full. And N1 is common. Is common. Right, now this is much more fuller, intense. Right, now let's see which one else can we prove. Can we prove that Q is equals to P? Let's see, and it's Q1 is equals to P1. Yes, we can prove that one very well. So we can prove that Q1 is equals to P1. That's the angle we're working with. P1. All right, let's do this once again. Let me rub these highlights so let's just pick one of them. We said P1. That's P1. It is subtended from n, subtended from n, let me highlight it, subtended from n q, like that. What else is subtended from n q, you ask? Well, it is actually that angle q1 right there. Okay, so then we can say same seg as the reason, same seg, and you must mention that seg, it is n r. Okay, and then this last one, r and s. Okay, we need to mention them. It's just I've rubbed my triangles, but that r is basically nqr, and qr is basically nrq, nrq is equals to, and then the s, what's that s? It's actually just s2. Yeah, at least that one has been named s2. Okay, and remember where I found it. Basically, if you're struggling to see where am I taking it from, I'm taking from, remember the triangles, it's NQR, and then the other one is actually NPS. So these are the two triangles. So now I'm proving this S2 being equals to that whole R. Okay, and then there's two ways you can either say it's a third angle, or just sum of angles in a triangle. Okay, it's good enough. Therefore, we've proved all angles congruent. Therefore, we can rewrite the statement that we were given, NQR. Oh, no, we're not looking at angles this time, so you rub that cap. We don't need it. Triangle NQR is congruent to triangle NPS. And the reason angle is how we proved it. That is how you prove it. Okay, let's do the marks here. So 1 mark for that. It's a 3-mark question. 1 mark for that. No mark for this third one. And then final mark for mentioning that it's angle. Very important. If you don't mention that angle, you lose the mark. Okay, let's look at marks on this one. So 1 mark for all of that. Statement and reason. Second mark there. No mark for this third one. But there is a mark for mentioning angle. Well, that's it. Thank you so much for tuning in. Please like and subscribe on our channel, and I appreciate you.